to my colleagues in material science engineering and let them get started. And I think I went the wrong way. Yeah, I'll get them to turn it on.
Okay. Good evening, everyone. My name is Michelle Samansky. I am the undergraduate academic advisor for material science and engineering. The first thing I want to ask you guys is, what can you make without a material? And the answer is nothing. Okay? Everything in this room, everything everywhere is made of some kind of material, and that's where we get involved. Sorry, Cole Harse is here with me. He's a senior, and he'll talk in a couple minutes. Sorry. Material science and engineering is the study and the science of how things behave and what they do. Then they take that knowledge and they engineer it to do what we want it to do. Okay? There are four main disciplines that we focus in. There's metals, ceramics, polymers, and electronic materials. Okay? And there are several subsets of these, from biomaterials, composites, and the list goes on. Right? Yeah. So let's first take a peek at metals. Metals are, actually, Cole, you do this.
All right. Yeah, so metals, they're essentially just very resilient materials. You guys all know metal is, you guys have seen steel. Anyway, yeah, so they're resilient materials. They're able to flex and accommodate to load while also being conductors of heat and electricity. So you find them a lot, for instance, like copper wires within electronic systems, or even just in power cords that you see above us. Some examples of different things that we have are aluminum aircraft frames, which are super light but are able to accommodate the loads. Magnesium transmissions, titanium golf clubs, just be able to be super stiff while also being super light. Zinc electrical hardware, bronze gears, and biomaterials. So for biomaterials, stuff like that, there's some materials that do not react well with the body, and we want to make sure that we don't have it happen so that your arm doesn't turn purple when you break your arm. But yeah.
Let me interject and say another example of that is my knee replacement. I had my knee replaced 3 years ago, and the materials that they're using today, my knee would last me 20 years, whereas before it would only last 5 to 10 years, and that's because the body's trying to get rid of that foreign object. Okay? So we'll go on to ceramics. More about ceramics.
Yeah. So next is ceramics, and ceramics are essentially your go-to material for anything that's super extreme conditions, so super wear resistant, heat resistant, temperature resistant, sort of all that sort of realm. Cement is the biggest one. It's the most consumed material in the world, most consumed product in the entire world. Roughly 50% of all materials made are cement. You have glass, which goes to everything from iPhone screens to windows to fiber optic cables connecting all of us, and the manufacturers of equipment for aerospace, automotive, marine. So ultra-high temperature coatings that are seen on a lot of aircrafts and airplane nozzles and stuff like that, just making sure that when they're entering and exiting the atmosphere, they're able to maintain their structure and be used time and time again. And that was a big thing that SpaceX actually had to do so we can have those relaunchable rockets. And also biomaterials as well. Your bones are actually a ceramic, and so if you break your bone and need a bone replacement or some sort of scaffolding, we need to make sure that we have something that's comparable to bone, and so it's up to us to alter material properties to fit that application.
So before we talk about polymers, and what I have up here is a tennis racket, and this is the evolution of a tennis racket. Does anyone know what the original tennis racket was made of? Wood, yes. What were the strings made out of? Go ahead and yell it out. Gut, yes, animal gut, primarily goat gut, okay? So the advancement in material science allows us to save goats. Right? Okay, so there have been many advancements. These rackets here, you can see, range from I don't have my glasses on, the 1870s to modern day times. And that is, they're lighter, they're stronger, they're more flexible, and they last longer, okay? And we don't have to sacrifice goats. So, you want to add anything?
I mean, polymers, and you guys mostly know them as plastics, are being more and more used just because they are so easy to produce. They're very easily moldable, shapeable, and easy to make in bulk quantities as well. And they have allowed for a lot of our everyday commodities to be a lot cheaper and more accessible to everyone.
last area that we're going to talk about here, well, is the electronic materials. I'm going to age a couple people in here. Did anyone have a bag phone? Yes. Okay. That was the early cell phone. It was this big bag that we carried around with us, and the battery was like the size of my fists. It was huge, and you can see the evolution of these cell phones here. Material science has played an important role in all electronics, from this to sensors, and so much more.
Yeah, and so like one of the biggest sort of innovations in material science and in the efforts of advancing electronic materials is EUV lithography, which have you guys ever seen like the video of just like zooming into a circuit board and just seeing just the system of interconnects and sort of just like all the little pieces that go into it, just even on like sub-micron scale. Have you guys seen that? Yeah, so that's was entirely done through just knowing the material properties of both the laser and the substrate that you're working on. And chips and computers are getting smaller and smaller, and a lot of the innovations that have to be made in those is on the material side. We can design circuits as optimized as we can, but if the materials can't uphold that, they won't perform to the way that we need them to. And yeah.
Yeah, okay. So again, coming back to material science and what is it? It's the science of everything, and how do we engineer it to do what we want it to do? I'm going to ask a very broad question here. Who has made a cake from scratch? Anyone? From scratch. Okay. So you guys know that there's a proper procedure, and that a baker, actually a scientist, has determined that this is the process. You mix this, step 1, step 2, step 3. A material scientist is going to ask, is that the best way to get a cake? What if we mix it up? What if we add the sugar to the flour and then add in the butter? Are we going to get a better cake? Okay? So in a nutshell, that's kind of what they do in the lab all day long, is play with the process to get the best outcome. All right? And have you ever left an ingredient out? That's another aspect of it. So what happens if we leave the egg out? All right? You don't think egg adds that much to your cake, but it's actually the binding agent that holds it together. So if you forget the egg, you're going to have crumble. And crumble's not that good. So I like to say, and I think I've gotten called to say this as well, material science is the center of all engineering, because you cannot make something without a material. Depending on what industry you're interested in, there's a material scientist there doing that work. Okay? MSc at Virginia Tech, we have 24 full-time faculty, several adjunct. Right now in our department, we have about 150 undergrads. Our undergrads are in the lab every semester. You want to talk about the labs for a second?
Yeah, so starting off in your sophomore year when you actually decide to go to MSc, essentially there's a sequence of labs that you take, just getting more familiar with materials processing and, more importantly, materials characterization. Understanding why the things that you were doing led to certain microstructures or leading to certain, what's the word? Just properties of that sort. Yeah, and yeah, characteristics. And it sort of just builds through this entire just sequence of understanding more about materials processing and materials characterization until you eventually reach your senior year, which you are given a senior design project where you're working with a few other students within the major. You're assigned to a professor, and you do a pretty cool project with them. Just go through the entire research process, material selection, materials design, into application. You do the testing, you do the characterization, you do the processing, you contact people in industry to find out what they want out of everything. You go through this entire process to then make something that's good. So it starts very, very general, understand the basics of everything, and then focuses on one specific thing, and you will become that subject matter expert on it. And we have a bunch of different projects, so no matter what realm you like, whether it's for metals, telecommunications, electronic materials, biomaterials, nuclear materials, cements, metals, we have a senior design project that will allow you to focus in on that and be really good at it.
We've actually, in the past, we've had senior design teams who work on the surfboard. So that's not a big industry here in Southwest Virginia, but we work on the surfboards and design the final layer of wax that goes on there so that it repels the water properly. They have done research on guitars and how they're made and the final coating that goes on an acoustic guitar so it has that ultimate perfect sound. So, MSc careers. So you can get hired with an MSc degree anywhere they're making something. I have students working in every industry from Yankee Candle to NASA and everything in between. Right? This is one of the faster growing fields. I did some research just yesterday, and the Bureau of Labor and Statistics says that the MSc field is growing 7% faster, and that is above average for all the other disciplines. Just gonna throw in some things here. This is gonna be posted, and you guys can go back and pull this up and see Neil deGrasse Tyson talk about sports materials, and Bill Nye talk about the material science field and the greatest invention because of materials. Okay? Just throwing those out there for you. I'm going to let Cole take it away again.
Yeah.
Kind of covered some of this.
Yeah, I covered a little bit. So essentially, the biggest draw for materials engineering is just the amount of things that you can go into. It's truly a limitless major in terms of what you want to do with it. As we said, you're essentially the center of anything. So even if you are interested in like computer engineering or mechanical engineering or civil engineering, you can still work in those fields with material science, but then also be able to branch out to complete other industries and make your impact just pretty much everywhere. And you can really walk into a room with any engineer and at least have some semblance of what's going on and have a conversation to advance the problem or advance the solution further. And as we mentioned, there's only about 150 undergraduates within the major. We are one of the smallest engineering majors on campus, but that means you get a really close-knit community. So you get to know every single one of your classmates. You get to sort of just like first 15 minutes of class is something I look forward to every day. Just I walk around the classroom, check in on everyone, go grab drinks after if you're of age. And then, yeah. And then also just working on design teams, stuff like that. Like I've built just super close relationships with not just my classmates, but also professors, advisors, and everything in between. And then also courseload tailored to your interests. Like I said, your senior design project will be the culmination of everything where you focus on the thing that you're actually interested in. And also there's a bunch of conferences and competitions, which I'll touch on a little bit more, which is one of the things that I've gotten the most out of the major was the design team competitions. And so we've done everything from making replicas of Thor's hammer to next year, or actually this upcoming year, making a replica of George Washington's sword, to making a firefighter's tool to help open up doors, making unbreakable mugs. If you like disc golf, we have a ceramic disc golf competition, and just a giant range of absolutely everything that you can do. Also, we have lots of really cool classes. We have a bladesmithing class where you learn about the science of making a knife. You get to make your own knife. It's pretty cool. Also, we are one of, I think, 30-ish colleges in the country that have a foundry on campus.
The only one on the East Coast?
We're the only one on the East Coast. And so we actually have a foundry on campus where you can melt metal, build the compositions yourself, and make anything that you can think of. And we have classes. We have AFS, American Foundry Society, which is a club within MSc that allows you to just get really familiar with the foundry. And there's a lot of good job opportunities that come from that as well. Also, we host a career fair every spring. So we will try our absolute hardest to make sure that you get a job or an internship or whatever you're looking for. Just try to give you all the keys so you guys can be successful. Lastly, there's outreach communities. There's times where we go to elementary schools, middle schools, high schools, go talk to you guys like I'm doing right now, and just sort of educating people about material science, because materials are everywhere, but not everyone knows about material science. And so being an ambassador, I get to spread that knowledge and hopefully bring some more people in, and overall just get to do some cool things with the thing I've spent the last 4 years on.
Yeah, okay. This is one last thing. Material science, and I have mentioned, and Cole has mentioned that it's everywhere and in everything. Let me back this up and ask you guys, did you ever have any action figures when you were kids? Everybody? Action figures? Okay. How often did the arm fall off? or did the head pop off? Not on purpose, but how many times? So it's designed to do that. All right, this is the one area of material science that I am kind of upset with. They know how to keep that arm on there, but if the arm stays on, you're not going to ask mom and dad to buy another one. Right? So it's in that area where material science is actually working to advance many things. Everything from medications to shoes to cars, we're advancing. And actually in toys as well. I mean, you guys don't have the same easy bake oven that I did. And that's actually a good thing. So material science, again, it's everywhere and it's everything, and you can't do any engineering without it. So Kobe's not here tonight. This is Cole. Our information is going to be shared, so you guys feel free to contact us or stop outside and chat with us. And I do have some of the samples that they have taken to, on their design competitions and won with. So you guys can come and check those out. So I'm going to invite up next is BSE, and they're going to take over.
So good evening, everyone. I have to get my timer set up so I stay on time. If you get an opportunity to visit the Foundry, it is really cool. I definitely highly recommend it. And usually there's an open house in the fall. Is that correct? October 19th. So go check it out. It's a nice little bike ride down towards the one side of campus. My name is Darrell Scott. I am a professor in biological systems engineering. And my department that I'm going to talk about today is well, it's BSE. I'm in two colleges. So I'm in the College of Engineering, and then we're also part of the College of Ag and Life Sciences. And so it's a little bit unique in that sense. And I'm going to share with you what our undergrad program's like, what we do in our community, and kind of just give you a snapshot. It's hard to do this in 15 minutes, to be honest. So we'll see how it goes. First thing I'm going to share with you is that we are a smaller community, and we use biology to solve big problems. Recently, last week I was in the middle school for my kid, and I walked into the science classroom. And I came up to a poster, and there was a poster with Albert Einstein. And the quote was something like this. It said, "We cannot solve our problems with the same thinking we used when we created them." And I think you all have this opportunity here at Virginia Tech and across all of our disciplines to solve problems that we have facing society. And we do that in BSE using biology. That's one of the unique things about our program. I'm going to share with you how we're invested in your success and to truly make a difference going out into the world and face some of the challenges that we have. Let's see. So to start off, our community is pretty small, and that does mean, just like in material science, that you get a lot of attention from your professors, from our advisor. You get to participate in undergrad research, which I'll share with you, and we do have a lot of fun. So this is just one example of some pictures showing from some of our classes. We had our outstanding College of Engineering senior last year was from our program. And then in the top left picture, you see one of our students presenting their senior design capstone project. Here's a wide range of pictures of folks from alumni and people during our program. And you can kind of see from some of these images a lot of the fun things that we do and some of the internships and jobs that we celebrate the successes that we have of our students along the way. So I'm going to want to break down what BSE is. I'm going to break it down into words in a real simple sense. Obviously, the word biology, right? It relates to living organisms and living things. And so our discipline thinks a lot about incorporating biology into that word systems. And so the word systems in this case is thinking about how things are connected together, right? You might have attended industrial systems engineering, It's another discipline that really thinks about systems. Biomedical will also include systems of the human body. But what we're doing is we're really trying to think about how we design and build and put things together. And then the word engineering is the branch of science and technology concerned with the design, building, and use of engines and machines and structures. And so we combine biology, systems, and engineering all together to solve problems. The kind of scales that we look at range from being very small at the subcellular level to large macro ecosystems. So to the regional level across multiple states, you can think about solving problems. A lot of the work I do is thinking about solving problems across the United States in large river basins, and some planetary challenges as well. The time scale that we end up thinking about when we're studying the systems of interest might range from processes that happen really quickly and over a very short time scale to millennia. So I want to give you a flavor of some of the complex challenges that we have in front of us as a society and the role BSC has in those. The biggest one that I see from my perspective, and it can be daunting and scary at times, is our growing population and climate change. How do we feed everyone on our planet in a sustainable fashion while maintaining human well-being, maintaining our ways of life, and doing it in an equitable way, right? That is a big challenge. I know I have a 25-year-old and a 21-year-old. Actually, my middle child's turned 22 today, so now she's 22. But they both talk to me a lot about the challenge of the world we live in now. And I would argue that there's a lot of hope for all of us, especially hope when I work with you all as students, that we can make a difference to some of the big challenges that we have. So what I want to do is share the two majors that we have within our program. And our first major is, it's called Biological Systems Engineering Major, same name as our program. We have 5 main curricular pathways. We can focus in a couple, the 5 pathways are biotechnology, health, food, environmental health engineering, and ecological engineering. And for the purposes of time today, I'm going to focus on biotechnology. So when you think about biotechnology, it's actually a really exciting time that we're sitting in today. And when I think about the possibilities over the next 2 decades for some of the problems that we have in front of us, biotech is right at the forefront. And I'm going to show some data to kind of help you understand this. The first thing I'm going to point out is the growth in bioengineering and the bioeconomy. It's been quite high, and it's only growing. I'll share with you some of the advances in technology and the engineering tools that we're using, and then some of the applications. So I didn't quite know how to show this in a very easy way, so I went to the stock market. And money's not something that, frankly, I actually think about too much. As long as I make enough money for my family, I'm pretty good. But I know like the BSE major being small, some of us need to think about, can you make a living out of it? And the answer is yes. To show you that biotech has an incredible future ahead of it, I pulled up a stock here. This is Lilly, and you can see the comparison between the yellow-orange line relative to the S&P 500, which is the lower slope. It suggests that the biotech, the emergence of biotech over the last decade, 15 years, is on an incredible rise. And with the abilities that we have in today's society and the technology we have, it's only going to increase and really be part of increasing human well-being across the world. So it's an exciting time. We see with the advent of genome editing, it has really opened up a lot of the doors to be able to do a lot of the cellular engineering that is working towards creating new pharmaceuticals, working towards food applications. And this is just an example of looking at the number of publications. And so one of the ways my currency as a scientist is publications. And when you look at this graph, you can see beginning in around 2010, 2011, the number of publications using these tools has significantly increased, and it's on the rise. So it's exciting from that perspective too. In biotech, one of the ways that's a little bit different than some branches of engineering is a lot of what we're doing is we're learning while we do it. And there's a concept called DBTL, design, build, learn, or design, build, test, and learn. And so in our program, when we, with our students, we help them understand how to design a process, build it, and then test it. And with biology and small cellular level stuff, you have to test it a lot to see if it's going to work, and then you learn from that and then repeat. So it's kind of, that's where it's the blend of science and engineering at the same time. One of the tools that allows us to do this at this moment in time is robotics. And robotics has really come to the forefront just over the last 5 years. Here at Virginia Tech.
Tops of the tubes are out of the way.
Hold on. I'm going to turn off the volume. Here at Virginia Tech, and in our program, we're one of 5 or 6 schools, not many schools, I think there's 5 or 6 schools up here that are using robots in the classroom as part of a hands-on lab to build and test processes in terms of being able to manipulate genes and add proteins and learn from that process. So right now, this semester, we have sophomores and juniors that are in this class. Some of the advances that we're seeing, we have I like dogs. One of the professors and the students that he works with, is Ryan Singer, is using advanced types of numerical methods and matching that with chemical analyses to look at patterns. And pattern recognition allows him to understand and explore where there might be disease without invasive measures. Pretty cool stuff. And so you'll see in all of our branches of engineering here at the college and within BSc, we're really exploring the use of machine learning and AI to help really push us to a new level. We have research that goes on and students that get involved and go out in industry looking at pharmaceutical development. This is a picture of Dr. Zhang, who teaches our protein engineering class. He's one of the world's experts in vaccine development, which we've all learned a lot about over the last couple of years. We also have a lot of waste that we create across the world. And one of them's in the agricultural space. And when you have waste, we have to figure out what can you do with it, right? Do you end it up in a landfill? You can also think about different byproducts or different energy that's embedded in that product that could be used for something else. So think of that as, I teach green engineering, I think about it as industrial symbiosis. And what our researchers are doing, and students, we have undergrad students involved in this as well, and I see it as something moving forward, it's really at the forefront, is taking waste and turning it into something else. In this case, they're creating biomaterials and bioplastics. And we have a pretty cool scale-up lab at Virginia in one of our buildings where we can take bench scale processes and turn them into something that industry is creating. Switching to the second major, we have a new major within our program called ecological engineering. And this is at the center of merging a subcomponent of biology called ecology with engineering. And the idea is largely to address some of the large environmental issues that we have out there and thinking about a large watershed system or planetary type of system. So in this kind of design program and major that students take, it's more specific and really tailored to students that want to work in the environmental space. And there's a lot of jobs right now in this field as well. This is a video that showed up on the Virginia Tech News about one of our outdoor laboratories that our students have. And so we have, in my program, called the Stream Lab, where students have the opportunity to work outside and understand and quantify and measure different processes that are going on across the landscape. As I mentioned, the major is pretty specific in terms of the courses, so there's less flexibility compared to the BSE major where there's multiple course pathways. Two examples of work that ecological engineers might do. One is creating what's called some type of in-stream structure to slow water down. In the scientific world and the ecological engineering world, they call these beaver dam analogs. So in the absence of a beaver, you can create a dam, a small dam, to slow water down and improve water quality and create habitat for fish and other critters that live there. We could also look at a much larger system, and we have a lot of land use development going on across the United States and the world. And thinking about how water and pathways are connected together becomes really important to understand what we can do to help solve and slow down water in this case, and improve the water quality for downstream water users, which is us, when we pull water out for drinking water. So things that you're going to learn in BSE range from getting a really core engineering and science background. You all are starting that this semester, and you'll continue that through your freshman and into your sophomore year. We have courses in data science and analysis, which becomes really important for all of us to really leverage AI and machine learning moving forward. We focus on problem solving and design, so there's design experiences embedded throughout the curriculum. And one of the things that I would argue is one of the most important things that we provide in our program and across the college is power skills. So that concept of teamwork and communication and be able to share and talk about what you do. And so as you explore Virginia Tech, take advantage of those opportunities for sure. We do pride ourselves in our individual attention. Ms. Baker's our advisor down here in the front, and she works with each and every one of you, each and every one of our students, to really think about what is best for them and how can they get the most out of their college experience. And so to give you some examples of that, let's see, well, the slides just shows we're committed to your success, the professors in our program. The opportunities that you have, things include undergrad research. Everyone does a senior capstone. And then we've worked hard to design opportunities for study abroad and service learning. Here's a list of different undergraduate research projects, all the way from growing plants to understand how they work and changing some of the genes inside of them, to measuring water quality in a karst cave system, to exploring water quality across Virginia, to thinking about pathogen detection in foods. So students have a lot of opportunities to get involved in undergrad research. Our capstone projects are a year long, the senior year, and students pair up with faculty and industrial mentors as part of the capstone project. That's far out from now for all of you, but it's a pretty fun culmination experience the senior year. The one thing I will note is that we've been fortunate in our program. We've had the last 3 years first place in the ASABI competition for senior design projects, which is a big deal. And that's the national organization, or international organization for ag and biotech engineering. We have students involved in study abroad experiences across the world. Right now, I know we have at least one student in Ireland, And I don't know if we have anybody else right now, but we have students every semester that are participating in things. We have service learning opportunities. Maggie, our ambassador, is probably going to mention or can mention that later. She was able to participate in a service learning opportunity in Nepal in May. And then we also have opportunities to get involved in what's called extension. So here at Virginia Tech, you're actually at a land-grant institution, and we've heard about research, we've heard about our undergrad program, but we also have professors that are really engaged in bringing the science to the Commonwealth of Virginia. And this is one example. Erin Ling coordinates a water testing program for people that are on wells all across Virginia. We have students that help out and get involved in this project every year, which is pretty cool, and there's other extension examples for students. Careers, there's a lot of career opportunities, and I do honestly believe that both biotech and ecological engineering, there is so much room for being part of this growing discipline and really contributing to some of the challenges that we have today. So with that said, there's different ways to connect to us. Reach out to our advisor at BSC Advising. You can always reach out to me. My name again is Darrell Scott. I'm going to pass the baton to Biomedical to Sarah, Dr. Arena.
All right, y'all, I'm gonna try something that one of my instructors taught me the other day. So give me a clap if you can hear me. Give me 2 claps if you can see me. It's a little hard sometimes because I'm pretty short, so that's why we do that. All right, so I'm gonna start off with a quote, and this quote is, it's one of my favorites, is courage is knowing it might hurt and doing it anyway. Stupidity is the same, and that's why life is hard. So I want to congratulate you on your courageous decision to come to Virginia Tech to the College of Engineering. It might not feel like a courageous choice all the time. It might hurt. It might be hard. But ultimately, you will absolutely love this decision and you will love your time here. And you're probably thinking, what is this crazy lady doing up here right now? But I am living proof of that. So I, as actually more years than I would like to admit verbally or commit to, was just in your seat. So I am a 3-time Hokie. I got my undergraduate degree in engineering science mechanics with a concentration in biomechanics. That was before Biomedical was a program here. And then I got my master's in biomedical engineering through the UGG program, which if you have not heard about that yet, definitely look it up. And then I stayed for my PhD in biomedical engineering. A couple years, went to some different places, and then found my way back home to Virginia Tech, where I'm now the BME undergraduate program chair. So one of the big questions that I always get is, what is biomedical engineering and how does it differ from other things that we have here? So the short answer is, anything that has to relate with health is biomedical engineering. And so the pictures that are up there kind of go across the full gamut of what you can do with a biomedical engineering degree. You can be looking at the super small scale, looking at cancer level or cell level cancer therapies or other mechanisms for targeted disease or limiting disease progression. You could be working at the organ level and developing tissues outside of the body, possibly for reimplantation or for organ transplantation down the road. And you can be looking at larger scale. So for example, different materials and things like that related to one of our leading labs, the helmet lab, looking at what is best to prevent concussions within our football players as well as a multitude of other sports. And then also at the whole body level, which is what I do, human movement and biomechanics. So the vast different fields that we have here at Virginia Tech, again, range, there's a very, very big range here. So when you're thinking about what you want to do with your biomedical engineering degree, it might seem very broad. So this is the Blue Ridge Mountains, right? It might feel like there are way too many possibilities out there to think about. But what we are going to do is we're going to help you find your passion within there. Even if you try a few different mountaintops before you get there, we're going to get you there. So how are we going to do this? We emphasize hands-on experiences, and we do this throughout our entire curriculum. For example, in Intro to BME, one of the first courses that you're going to be taking, we give you a medical device and we let you smash it apart. And I mean that literally. We give you a hammer and we let you smash it apart. We also have a lot of hands-on labs. This is a picture from our cell engineering lab. So here you are actually growing mouse cancer cells and you're applying different techniques and different analysis methods to the cells throughout the entire year. We also have a bioinstrumentation lab. This is where you're learning how to build different circuits and different sensors to be able to interact with the body and measure different things. This is another picture of that where they're actually putting on a strain gauge to a rib that was taken out of a pig. There's also a lot of hands-on opportunities within our technical elective structure. So this is an example from my course, Musculoskeletal Biomechanics, where we're looking at different ways we can analyze human movement, as well as understand potential mechanisms for injury and rehabilitation of injury. Then we also have immersive experiences through our needs identification course. So this is an example. They actually got to go to the Surgical Simulation Center up in Roanoke, and they're going through, and essentially the purpose of our needs identification course is going out to people and finding out what their problems are. This includes caregivers, this includes physicians, nurses, patients themselves. What can we do and what can we design to help you? How our BME program is different from other places is we have a very unique focus on fundamental engineering principles. And this is very purposeful because we want you to be able to apply it to whatever you want to do. As you saw, there's a lot of things you can do in BME, but you need a good foundation to be able to apply it to where you want to go. We also have one of the highest number of technical elective credits. So within the BME degree, you have 21 credits of technical electives. What this means is you get to pick and choose what you want to do. This lets you tailor your degree to that specific area. So remember I said BME is pretty broad? Well, this lets you pick the credits so that you can specialize where you want to. There we go, flexibility to tailor your degree. All right, so what is it like majoring in BME? So the total credit count is 124 credits. The nice thing about this is it allows you a lot of flexibility with your degree to pursue additional options. So for example, we've had a lot of students choose minors in completely unrelated areas because it was something else they were very passionate about. Disability studies, Spanish, psychology, any of those. You have that room and the space to be able to fit that and still graduate in 4 years. We also offer you guidance on how exactly to go about those technical elective choices so that you can really hone your degree to what's going to be best for you. When we talk to our students about the different areas, we try to tell the technical elective choices into 3 different kind of categories, or bigger categories. One is biomechanics, another is biomedical devices and imaging, and another is cell and tissue and engineering. So an example of a really great minor, still kind of related to your, well, very much related to your degree, but for example, people that are interested in biomedical devices and imaging, we highly suggest getting a computer science minor because 1, you have the space for it, and 2, it is really helpful and really adds to your degree to be able to apply some more of these biomedical applications outside of that space. We have a lot of experiential learning opportunities, so I know there's a lot of chaotic pictures up there, but we're going to kind of step through the different options that we have. So we have undergraduate research and a 60-60 program. So the 60-60 program is essentially the department will pay for 60 hours of your undergraduate research, and then a faculty member will pay for the other 60 hours. This is a great opportunity, and it's also a great leverage for you to be able to get into those labs a bit earlier. We also have a lot of our students complete internships and co-ops. An example of this is Medtronic, as well as, oh my gosh, my mind is blanking, Carillion Clinic Innovations, which is up in Roanoke. We also have our students participate in different design sprints. So actually one of these pictures that is up there in the your right, is an example of one of our senior design teams that got to go to Minnesota and do a design sprint with the medical device company Medtronic. So that is a really unique experience to be able to go and do that and get immersed within a medical device company. There's also different design sprints we've done with Johnson & Johnson in their incubator hub at J-Labs up in Washington, D.C., as well as other ones focused on rural health applications. We also offer a lot of clinical immersion. So again, an example of our needs identification course is students are actually going into different hospitals up at Salem, VA, also at Walter Reed up in Washington, D.C., to really identify what are the needs of people that we can create solutions for. Ultimately, by the time of graduation, 89% of our students have done some sort of undergraduate research or internship before they've graduated. Advising in BME is by Miss Amanda Sandridge. She is up here in the front, and she'll be here for the Q&A. So if you have any questions, please feel free to reach out to her, and she also takes appointments through Navigate. One of the take-home messages for your parents when you're talking about which major to declare is we are ABET accredited. So biomedical engineering is a new program. We've graduated our 3rd cohort, and we do have ABET accreditation that is retroactive to all the cohorts that have graduated. Finally, if you are deciding that maybe a BME major is not for you, we also offer a minor. So the BME minor is 18 credits with 2 required courses, Intro to BME and Intro to Medical Physiology. We also have 6 credits where you do some sort of BME research or some sort of BME-related senior design project. So for example, typically your senior design project in your home major can count as long as there's some sort of BME application to it. Then there's additional 6 elective courses, which you can kind of consider like technical elective courses. All right, don't know what that white stuff is on top, but student organizations and clubs. So there's a lot of interdisciplinary student organizations and chapters that have some sort of focus on biomedical engineering. And these are open to everybody, but most of these are housed or have a faculty advisor from biomedical engineering. So one of them is bioactivity. That's the top picture up there, is actually one of their projects pre-COVID, where they were working on a bariatric lift for ambulance drivers to be able to work with obese patients or to be able to get them into the ambulance safely. eNABLE is actually a national organization for which we have a chapter, and they are 3D printing prosthetics for individuals in the local community in need. So I'm going to say that again. If you're interested in prosthetics, which I know a lot of people are, that is definitely a club to look in. So this is actually the lower picture. This is one of the challengers that they've been able to help. This is a young boy who is a quad amputee, and they've been building different prosthetic devices for him because he loves sports and being able to make different ones for the different sports he wants to do. We also have the Undergraduate Biomedical Engineering Society, which is one more for professional development and getting you out there, resume tailoring, mentoring, and things like that. There's also a chapter of Engineering World Health, looking at global needs for improving the human condition, as well as the Maine Biomedical Engineering Society. All right, so careers in BME. Traditionally, what we say and what we've seen nationally is that a 1/3 of students tend to go to industry, a 1/3 tend to go on to a graduate or a clinical degree, and a 1/3 go on to, say, government or research labs. So we've only had 3 cohorts graduate, but we can kind of already see we are on a similar trend. And one of those things that I had mentioned earlier, the UGG program, is part of that reason. So at Virginia Tech, there is a program called the Undergraduate Graduate Degree, which means if you have a certain GPA by the end of your junior year, you can apply and essentially double count courses from your senior year towards a master's degree. And you can use that between different engineering programs. So for example, bachelor's in mechanical, master's in biomedical, bachelor's in biomedical, master's in mechanical. You can kind of cross between the disciplines. What we have seen, though, from our first 3 cohorts is by the time they're graduating, which means in May, they have 80.3% of them already have where their first destination is going to be after they graduate. So the different types of careers are where we've seen our students go. You'll notice there's a lot of medical device companies up here. There's a lot of consulting firms up here as well. There's some automotive safety as well. Cell Inc. is actually a company that does 3D printing of cells for tissue engineering applications. But you also see some government. So we've had some go to the patent office as well as NIH. And And so with that, I will do a plug. I know Expo is going on right now, but we also have our own Biomedical Engineering Career Fair that is in conjunction with the Biological Systems and Engineering Department. That is going to be this Monday, September 16th, and you are able to register in Handshake. So with that, other ways you can connect, again, there's the information for our academic advisor, Ms. Amanda Sandridge, as well as mine. So, thank you.
All right. It's been 1 hour since we all got here, so I need everybody to stand up. Everybody stand up. Stand up, stand up, stand up. Get a stretch in. And what I want you to do is turn to your neighbor, and I want you to give them the biggest high five and say, congratulations for being a Hokie. Woo! You did it. You made it to Virginia Tech. You became a Hokie. And not only just any Hokie, but an engineering Hokie. I don't know if there's any other better kind. So congratulations, have a seat. We're in the home stretch here. But in all seriousness, that's a pretty amazing accomplishment, something you should be really proud of. We are so proud, and we're so happy to welcome you to Virginia Tech, and we can't wait to see what you do over the next few years with us. So I'm here to bring us home before you get to ask the hard questions to the people who really know what's going on, the students. And I'm going to talk to you about mechanical engineering. So I'm a mechanical engineer. I've been doing this for a while now. I play one on TV and in the classroom. But the question is, what do they do? And what I was always shown and taught was like, oh, mechanical engineering. Actually, I had some roommates. I had like a aerospace engineering roommate and a material science engineering roommate. They're like, oh, why don't you go play with your gears? You big, mechanical engineer. That's all you all do is just design gears. It's like, no, we're much, much more than that. And then it's like, oh, and I get questions from like my family friends, like, oh, you're mechanical engineering, like, you know how to fix my car. It's like, no, not really, no, not necessarily. And maybe it's, it's all about robots. It's like, yeah, we do that too. But mechanical engineering is so much more than the prototype, the trope of, gearheads. Not that there's anything wrong with that. We love gearheads, and we are very happy to support you in that journey because it's a pretty rewarding, exciting time and career path, but we do so much more. So that's what I'm here to talk to you about. Fundamentally, what mechanical engineering is all about is about if you're touching a product, some mechanical engineer is involved. If you're dealing with something that transfers energy or is having some energy transferred onto itself or something that's actually been manufactured, which includes pretty much everything in this room, a mechanical engineer was involved. What attracted me to mechanical engineering when I was looking for a major was it was the broadest engineering major. It was something that I knew I could go to almost any company and they would be looking for at least one mechanical engineer. And there's the diversity of the things I was going to learn were going to help me find a job and a career that I would find rewarding. So we do machine design. We design machines to help transport energy and people and humans and goods. But we also do a lot of making of those machines. And we study the fundamental sciences that enable those machines and products to work, like how does heat transfer, how does fluid transfer, how does energy, like sound transfer and vibrations transfer, and how do we leverage all of that knowledge to make cool things like energy and power systems, robotics, mechatronic systems, and autonomous vehicles. So in mechanical engineering, you get the chance to really take a variety of courses that really could be applied to lots and lots of different markets. What really drew me to mechanical engineering, what I think is the funnest part, is that we get to really develop these core skills of being an engineer. I think this is probably true of all of our majors. We're all about design. We take requirements and constraints that are out there in the world, and we do some analysis, all the engineering science, we put it all together, and we build and manufacture and test and evaluate. So, we develop complex systems and work on building those systems to do this. Really, we're all about solving today's problems and creating future solutions for healthcare, energy and transportation, space exploration. It's, again, this adaptable, versatile major that really finds a home in a lot of different places. So what I thought I'd do for you this evening is show you a highlight reel of last year's capstone engineering design fair. So at the end of your 4th year, you do a full academic year. From August to May, you get placed into a team. You most likely have an industry sponsor, and they challenge you with solving a real problem that they have. And it's gonna take at least 6 of you, mechanical engineers, to solve that problem. And it goes, again, all the way from a blank sheet of paper, listening to what they need, what the problem is, coming up with a solution, and then actually building and implementing and testing that. So here is the reel. Let's see. I got sound. Is it working?
Scotty turned it off earlier.
Scott, we're free. So what you saw in that video was a pretty diverse collection of things that people have made. Everything from a bio-inspired bat to actually think about making a drone that might fly like a bat, to making assistive devices for those with disabilities. In fact, that one of the things you saw was actually a bobsled trainer for someone to train to be in the bobsled. You saw some devices that we took to impoverished areas to help with clean water and other types of challenges there, and pretty much everything in between. And of course, some cars is along the way, right? Oh, yeah, there we go. So what is the future of mechanical engineering? At one point, I remember when I was an undergraduate, senior year, there was this cover article from American Society of Mechanical Engineers. It's like, is all we are just gears and motor and engines? And no, it's actually mechanical engineering has a very bright future because of its diversity and adaptability. And so yes, it is about transportation. It is about electrical now. Of course, electric cars. And what I love the most about being a mechanical engineer is that I get to work with the other disciplines. Pretty much every engineering team I know has to have a mechanical engineer to help with the making and the planning and the product design. But we also need the folks, our friends from the other departments, to actually teach us about the context. So yes, mechanical engineers, the biomed engineers help design and think about prosthetics and gait, but the mechanical engineers here have to do the stress analysis also and help the production and things like this. So it's about this team, and that's, again, why I love being at Virginia Tech, because we have the opportunity to do that. Again, autonomous vehicles is a big area in which mechanical engineering is coming from. Actually, there's a local company called Torque. It's owned by Daimler Chrysler. It's built up from nothing from a Virginia Tech alum, a mechanical engineering alum, and they're designing autonomous semi-trucks. So if you see a semi-truck around town with a TORC, give it some birth because it's being driven by itself. Mechanical engineer doing that. Again, any kind of transportation, whether it's exoskeletons or flying vehicles, and of course robotics and autonomy and future of manufacturing, that's being driven by mechanical engineering. What else is being driven by mechanical engineering is all the kinematics for the robots. So when you need your quadruped robot to do the push-ups with the cadets on game day for all the touchdowns that are scored, you need mechanical engineers to do that as well. Okay, that was the least entertaining. Like, I didn't even get a chuckle. Got to work on my game. All right. So I'll share with you some stories of some alum. These are alums that worked with me in undergraduate research. Again, another hallmark of the Virginia Tech experience is that all the faculty are really excited for you to come talk to them and learn more about what they do in their labs and provide you opportunities to get some more exposure. And that's true of all departments and disciplines. Another good reason to be a Hokie. That's why we gave each other high fives. So I've got some former students, Genevieve up there, who was a big player in the Baja car. Grady Wagner and Josh are students of mine who did undergraduate research who now work at SpaceX. SpaceX had some pretty exciting news this morning as well. What's interesting about all three of them is they all went at separate years, but all ended up on the same team. Grady is the guy behind all of their printed motors. All of their printed rocket engines are designed by Grady, and he got that experience by taking a course in additive manufacturing or 3D printing, as well as some classes in aerospace about combustion and space exploration, and put all that knowledge together to be the lead designer and manufacturer on their printed engines. Josh jokes to this day, I see him on occasion, he goes, yeah, I just make Grady print all my parts for me. So he's a lead designer on some of the pneumatic controls, and Genevieve is designing all the grid fins that are helping with the landing of their large reusable vehicles. Michael is at GE, and he's in their additive manufacturing division as well. He was part of a team that set the world record for the largest 3D printed object, which was a big turbine motor for a wind turbine setup, and that's pretty exciting. And Michael was, again, a good grad of our program. He went off to do that. We've got Shannon. Shannon did some undergraduate research with me where she was looking at how do we 3D print from CT scans. Shannon also went to go work for GE and their additive program, and actually, again, graduated different years, but both ended up on the same team. Shannon's worked on lots of amazing engineering problems using 3D printing. One of her favorites, though, was when she got invited to be at the Met Gala to help design and manufacture a rose petal dress that was completely 3D printed. And we've got Ed, who works at Relativity Space. So just this past summer, that company launched the first ever 3D printed rocket. And Ed was a student of ours who graduated and has worked for 2 or 3 different additive manufacturing companies. And they're literally taking a robot and welding rings and making gigantic rockets, which is pretty amazing. So very different applications, all, again, using their mechanical engineering skill set. And there's so many more opportunities, and what I think, there's lots of logos here. I think the big takeaway is they're all different. We have people at Apple doing consumer product design. We have people at 3M doing some materials work and other kind of things. You have people at Michelin doing tire dynamics, but also some tire formulation manufacturing work. Eastman Chemical, they're a chemical engineering company. They, of course, hire tons of chemical engineers, but they actually just sent us an email. They need more mechanical engineers to come and help do some of the stuff at the plant as well. NASA, the guy who invented the Echo is a VT mechanical engineering alum. So Collins Aerospace, lots of aerospace companies, Raytheon, Exxon. Again, this degree can take you very far. Now, for time's sake, they cut out all the cool research videos, which I understand. But thankfully, they kept one, and it's another 3D print. So I think just to show you a quick video of some of the research we do. So, mechanical engineers are always about inventing the future. And so one thing we think about is like, what could the future of 3D printing look like? So instead of printing things layer by layer, 2D printing really, we're looking at coming up using robotics to actually tailor the way that we print in full 3D to dramatically increase the properties. With just this research alone, we're increasing the strength of traditionally printed parts by 8 times, which is a pretty significant gain. But again, we get to play with other friends. Over the architecture lab, they have a 10-foot robotic arm. And so our mechanical engineering students and our chemical engineering students and our material sciences students are going out there to help them with new polymers, new printing processes, and the architects and the designers are actually designing furniture and printing large-scale furniture for, I don't know, for fun, because it's awesome, because that's what we do here. We do cool stuff. And printing big models for the wind tunnel as well. So, whether or not you're a mechanical engineering student or not, we are the home to a tremendous number of large student organizations and design teams. We're well known for our large teams related to automotive competitions like Bolt and their challenges to build an electric motorcycle. And that thing can go very fast. They actually have to have a professional driver for that because its torque is so high they can go 0 to 60 at insane speeds. The Formula Car, where they design and build a complete race car, Formula Car in a single year, is pretty amazing and involves lots of materials, lots of manufacturing, lots of design and analysis. The hybrid electric vehicle team, where they're doing some electric vehicle work, making hybrid, again, sponsored by GM. So all of those students are very highly prized future employees. We literally have recruiters who come to the Wear Lab and just walk through those bays to find students because they know that they've got good engineering skills, they've got good teamwork skills, and they've got some good hands-on skills. Other teams we have are, of course, the Baja team in the upper right, where they make a Baja vehicle every year and take it around the nation for competing in off-road racing. We've got the Solar Car team, where they're building a solar-powered car and making it very aerodynamic. Again, that's with aerospace team students as well. So again, none of these are solely only mechanical, but the mechanical is at the core. And on the bottom right, we've got our Robo Grinder team, which is an international robotics competition. And they've got some really opportunities to travel around the world to compete with that. We've got the QL Plus team, which is a team devoted solely to making life better for those in need through engineering assistive devices in the upper left there. Our Auto Drive team, which is focused on autonomous vehicles. So they take the vehicle, but they add all the sensors. They learn about machine learning and AI and machine vision to drive the car itself. And we've got the Grand Touring team, which is a 24-hour endurance race team competition. Again, taking a stock car and adding to that to make sure it gets through the endurance. And our tech robotics team, which is sort of like, if any of you, again, if you've done your high school robotics competition, it's sort of a collegiate level of that. So, the people you need to chat with, mechanical engineering, we have some amazing advisors who make everyone's life better. Sarah Deisher, Hannah Trout, and Linda Vick, three truly excellent human beings who really take good care of our students. And we've relocated them so that they're in prime locations. So on the 4th floor of Goodwin Hall, you can find them and you can stop and navigate as a way to select your virtual hours. And we'll have a student as well, and one of our ambassadors for mechanical engineering to answer your questions. But with that, thanks so much. Enjoy the rest of the evening, and congratulations yet again.
Go ahead and get started with that. So the first question that we have is, why should a student consider your major? And feel free, as tables, you all can all answer it, or you can decide if one or two, just one of you want to answer it for each department. So we'll start with material science engineering first. Why should a student consider material science engineering? And you don't have to go forward, you can just leave it there, it'll pick up.
I just press this button, right? And I'm good?
No, it should be on.
Are we good?
Yeah.
Phenomenal. All right, yeah, so I presented up earlier. My name's Cole Harsa. I'm a senior in material science. Essentially why someone should choose material science is just the breadth of what you can go into. You can go into absolutely anything that your heart desires when it comes to engineering or anything for that matter. And also just a sense of community that you build with your classmates. Being one of the smaller majors, I take that as an advantage. You get really close with all of your professors. All the professors pretty much know you by name, and we have a deep alumni network that is willing to help out on even just like homework problems. And that is stuff that has happened, just reaching out.
All right. I do apologize for my voice a little bit, but my name is Maggie Scarborough. I am a senior in biological systems engineering, and I guess there are a million reasons why I chose BSc and why I love it so much and why I think everybody else should join too. But there's just a lot of opportunities like for research and getting to know professors and stuff. I feel like, excuse me, sorry. I have gotten to talk to a lot of the professors and get to know them on like a personal level. So that way I've been able to do research with 2 or 3 different professors during my time here and really get, I have a lot of experience that has meant a lot to the job opportunities that I've also gotten as well. So from that aspect, all the professors are like super welcoming and they love talking. Sorry, I'm so sorry. I'm literally recovering from a cold. But all the professors are like super willing to like get to know students and answer any of the questions. So like that level of like personal interaction is awesome, and like really just being able to like take your problems and take your concerns to them and have them, explain and work with you is so incredible. And our advisors also really like guides people through it, and like she'll just answer all the questions that you have. So it's just a great major, and I wouldn't change it for the world. I love it.
Hi, my name is Alex Grodsky. I'm a senior in biomedical engineering, and the reason I selected biomedical engineering is because it's proximity to the clinical world. I really enjoy that aspect, that how closely we're able to work with clinicians and actually establish a connection with our engineering designs to their applications and how they're going to be applied in the real world. So that's one reason that I selected biomedical engineering. Another is my time here at Virginia Tech. I've had plenty of opportunity to work with professors, and they're really, most of them have an open door policy, and I've taken advantage of just stepping in and asking about questions about either homework or being able to just talk about a project I'm working on, or even just like what their personal opinions, or like not personal opinions, but like their input on like my career advice or things like that. It's just been a really great opportunity to, I guess, advance my career, and I'm doing things I love every single day. And there's a lot of choice within the major, which I really enjoy as well.
Hi, I'm Savannah Peters. I'm a junior in mechanical engineering, and I chose my major because there's a lot of opportunities in terms of like when you get out of college, there's a lot of jobs that will accept mechanical engineers, and you can work closely with other disciplines. There's also a lot of opportunities with research. If you end up talking to professors, they all do like wildly different things, so you can really find what you're interested in.
All right, my name's Brandon Abram, so I'm a senior in mechanical engineering. I picked mechanical, kind of like what Dr. Williams was saying. Super broad. You can go into a lot of different things, right? So there's so many different types of industry that you can get into with mechanical, right? So of course, everyone automatically will think of gearheads or automotive type of engineering, but personally myself, I'm interested in like aerospace type of work, and with mechanical, you can go into that. So I'm taking mostly aerospace-related technical electives. So that's just one example. You can even do nuclear, energy, things like that. So super broad. That's mostly why I picked it. Definitely encourage you guys to take a look into it or select it as your major.
Excellent. So we'll start with the Biological Systems Engineering Department for the second question, and then we'll just kind of rotate around. What was the neatest aspect of your undergrad experience that you have taken advantage of?
Yeah, so I feel like I've taken an advantage of a lot of the stuff that our major has to offer, research-wise and like club-wise, I guess. So I'll touch on the research a little bit. I currently am working in 2 different research labs for BSc professors, one of which is with the STREAM lab. So I'm out there like taking soil samples and water samples and just getting able to like, get involved and out in the lab and out in the stream, which I think is really cool. I love to be outside. Then I also am like kind of doing a little bit of biotech work as well. I'm working in one of our lab buildings here, doing like some human urine analysis. So I am like checking out like, what kind of things are in there from more of like the biomedical aspect, seeing, how we can, take samples and correlate that between like cancer, kidney disease, stuff like that. So from that aspect, I feel like you can see like there's so many different things you can do depending on what you really like. And I kind of like both aspects of things, like both like being outside and both being in the lab. So that's kind of why I've done both things. From, I guess, the club aspect, I know that Dr. Scott mentioned earlier that I got to go on a service learning trip to Nepal this summer. So that is with the Service Without Borders Club, which is not exactly BSc affiliated. However, we do have a lot of professors and students that are involved in that club, and they lead it. So I got to go with 3 other BSc students and 2 BSc faculty this summer to build irrigation canals up in the high mountain elevations of Nepal, which is like super awesome, really close to Mount Everest. You could see all the mountains. It was pretty incredible, and I got like some really great scholarships from the BSc department, which really helped me with my trip, and it was just awesome. I never thought I'd get to go there in my life. I also did a study abroad program this summer after my sophomore year that BSc totally supported and just helped me along with scholarships and just like advising and all that good stuff. So I've really been able to like, take advantage of those 2 items, and I know that, there's a lot more things that you could do depending on what you really would like.
And then I'll start off with giving my reason of why I started or got interested in BME. I was a senior in high school and trying to decide where I wanted to go or what major I wanted to do, and I decided on biomedical engineering through a conversation with a man that I had a conversation with at a VA hospital in Tucson, Arizona. I was speaking with him and really decided that application of engineering within the medical field is where I really had a passion. And so that's kind of my background. And my coolest, I guess, anecdote from my experience here at Virginia Tech and within the biomedical engineering program was a course that I took last year, the needs identification course that we spoke about during our presentation. I thoroughly enjoyed my experience in that class. I was partnered with a clinician at the Salem VA hospital. She was a podiatrist, and I worked on identifying needs within podiatry. So we got to do clinical site visits. We got to interview patients and talk to them about like what they really want to see improved from a personal level, which I thoroughly enjoyed. And then we also took a big field trip up to Bethesda, Maryland, to go see Walter Reed, which is the President's Hospital. It's a really great facility. It's really well funded, and they have such cool technology that's at that location. So just being able to see that and see, additionally from that course, I got to develop some real world application and like real world experience, which I'll highlight. We have a lot of real world experience that we get when we are like through those technical electives, and that's something that I think is really unique to our major, that you're developing skills that you can put on your resume every single time you're taking a new class. So that was a great experience, yeah.
All right, so the neatest aspect that I've taken advantage of was like the research opportunities. I ended up getting into the origami engineering lab, and it was something that I didn't even know existed, but like completely went with my hobbies, so it was really fun. I focused on incorporating origami into space applications, so with like building modular things in space, transporting it there makes it a lot easier if you can compact it. Yeah, so that was really cool. Go ahead.
I'd say one of the neatest aspects I've taken advantage of was some of the labs you take in mechanical engineering, right? So, because it's so broad, you get to kind of dip your toes into so many different things, whether that's electrical components or aerospace design or automotive type work. One of the coolest classes I took was the mechanical engineering lab, which is what you take in your junior year. And they pretty much allow you to kind of dip your toes into everything. There's 6 total labs. Of course, my favorite one was where we actually got to design and build our own 3D printed airfoil and test it and create lift and calculate all the aerodynamic values for that, which was really fascinating. And then also, so far, I'm only about 3 weeks into the senior design project, but so far it seems like it's a pretty great experience. My senior design is designing and constructing a hypersonic wind tunnel capable of reaching Mach 6 with the Navy. So we're designing and constructing this for the Navy to be able to use for equipment and instrumentation testing and design. So it's pretty cool.
Definitely the neatest thing that I got to experience was just the design teams within MSc. Just raise your hand, who knows the show Forged in Fire? Anyone know the show Forged in Fire? So it's a show that's on the History Channel, and I used to watch this all through like high school and stuff like that. And the hosts of that show are judges for a material science competition. And last year I worked with me as well as 7 other MSc students, just really close friends of mine now. We work closely with the Blacksburg Fire Department to make a halogen bar, which is a force blunchy tool they use to pry open doors. And so we went through this entire process of designing this bar, doing material selection, staying up late at night making silicone molds, like almost everything we did on our own. It was truly remarkable, and we actually got to go to the Blacksburg Fire Department's like test site, where we got to literally break open car doors, car windows, open up regular doors, smash bricks, lit a dumpster on fire. All all for like making it was a really cool thing. And we got to make a video about it, and then we sent this bar off to this competition up in Milwaukee. It was us and I think 65 other material science programs across the country. We came second place, and there's a 2-minute video of Ben Abbott, who's one of the hosts of Forge and Fire, just gushing about the bar that we made. I wish I could hang a video on a wall. I guess I could if I had a TV in my room. But anyway, it was the coolest experience that I've ever had. I got to break a window, got money for it, and got recognized essentially nationally for the work that I did.
So those are some fantastic experiences. Would you like to add something else? Okay. So we'll start with biomedical engineering for the next question, and feel free to have everyone at the table answer if you'd like, or just one of you. It's totally your call. But as students are trying to determine the best major for them, what is the one piece of advice you would give them to help them make that decision?
For me, I had an interest and I guess a passion for the medical field, but I knew I didn't want to pursue medicine. So having a personal connection and knowing that that's what you can pursue throughout your degree as well as like once you graduate is something that I focused on when I was deciding on biomedical engineering.
For me, I think what helped me the most with deciding what I wanted to do was I talked to professors and like asked them about their research, and it kind of gave me an idea of what I could do with mechanical, just to see if it was something I was interested in.
Yeah, I would have to probably agree with that. Just, if you're, I wouldn't say mechanical is like a undecided engineering, but you could almost treat it like that because, if you really not sure what type of engineering, that's more technical than some other engineering fields, that is a great one to choose just because you can go into so many different fields with it.
My freshman year, I don't know if it's still offered, there was an undergraduate research seminar. That was a class I took, and from that, I just got to talk or listen to people from every single one of the majors discuss the things they do in that major. And just asking around, seeing what aligns best with your interest. And really just going around, I know it's cheesy, do what you want to do, don't chase the money. Money will follow. Everything, you'll have a much better time if you like what you're doing, not in just college, but just internship and job experiences as well.
I do want to add real quick, if you're torn between 2 or maybe 3, ask the advisors there, talk to them, talk to current students like Cole or anyone else, a current student, and even ask to talk to an alum. Talk to someone who's like 2 years out, 5 years out, about what they enjoyed about their program and why they chose it, and if they're using it today in their industry. So I know I can connect any of you with over 200 alum, but we'll just settle with a few. So.
Yeah, and I'll kind of agree with that too, where, reaching out to faculty, reaching out to alumni, reaching out to other students, like that's the best way that you're probably gonna get to like learn more about what you might like to do. Like, I started thinking that I wanted to be a chemical engineer, and I like kind of explored around asking people what they were working on, and I saw a BSc and I said, wow, there's a lot of opportunities here, and I asked some people that were in the major, and they kind of explained to me a little bit about what they did, and I was like, that's pretty cool, I'll give it a try. So like, don't be afraid of like not knowing what you want to do. Definitely just go for it. Even if you decide like, hey man, this is not for me, like this is the worst thing I've ever done, at least you know that now. Like at least you have some sort of basis to like, keep going and keep figuring out what you want to do. And I know like I'm a senior, I have 2 mentees that are under me that I'm gonna hopefully get to talk to and kind of like tell them about the things that I've worked on. I'm sorry, I really am. But I'm gonna get to talk to them about the things I've worked on, and hopefully that kind of like will steer them down the right path as well.
The one thing I would add is that the faculty that you all have contact with, we're all just people too. We care about your success, and so when you hear the commonality of coming and talking and knocking on doors to the advisors, to the faculty, the people in different programs, come and do it, right? This is an opportunity for you to explore across the college, and we definitely embrace that.
All right, it looks like we have time for one more question, and so we will start with mechanical engineering there on the end. What do you wish you had taken advantage of during your undergrad experience that you reflect on now that you wish you had?
So I'm still a junior, so I have some time to take advantage of this, but definitely joining the design teams. I'm planning on joining next semester when I have some more time to dedicate to it. But I feel like it'll definitely give you a boost in like working with groups. You'll become more collaborative. Working with different disciplines, you'll get experience with that, and you'll get to build a cool project. So
I agree with that. I was going to say the same thing. So unfortunately, there's not enough time in the day, right, to be able to do everything that you want here because there's just so many options. So, you know, you kind of have to pick and choose, but I would definitely recommend joining a design team just so that you're able to, you know, build and demonstrate and develop more teamwork skills as well as technical skills that are, you know, more like a workshop type of skill. That's definitely beneficial to know. Just as an example, being able to understand how things are manufactured is extremely important in the real world, right? Because you can design something great on paper and it might work and fix every problem you can think of. But you know, there's obviously a financial aspect, there's a manufacturing aspect. That's something that's kind of cool about mechanical engineering is that they get to teach you those different types of things. And so also with design teams, of course, that aspect is really important.
I think the main thing that I would have wanted to take advantage of is the research opportunities. I mean, a lot of the professors here are doing research, and a lot of them are doing really cool research, and just reaching out, seeing what simply just seems cool to you, and just trying it out. That's something I wish I took advantage of. But in terms of other things, just the power of being present in any of your classes, literally just be there, talk to people. You don't even have to talk to people, just be there. Just be there, absorb as much as possible. I didn't learn this until about my second semester, sophomore year, and my college experience has been very amplified because of that decision.
And I guess for me, like, I would say, like, you know, as cheesy as it sounds, going up to professors after class and just, like, introducing yourself, asking them questions, going to office hours, even if you don't need help, go and show your face, have them know you. That way, like, you're only building your own network. That way you can, you know, who knows who they know. Like, they might be able to set you up with a research opportunity, internship, a job. Like, there's just infinite possibilities for that. And that's something, you know, I feel like I've done a good job of, but I wish that I'd done that more, where I, you know, went up to each professor and was like, hi, like, I'm Maggie, like, nice to meet you, like, and just got to know them and got to know who they, like, their background, their story, and who they get to know. So that's what I would say you guys should do.
And I'm going to kind of switch up the theme over here, but I'm going to recommend, and this is something that I kind of figured out a little later in my career here at Tech, but I encourage you all to diversify your experience here at Tech. You're in engineering things day in, day out, and you're going to be involved in all of those design teams or research, and getting an experience here at Tech that's not engineering is actually something that I've really enjoyed, and I'm able to bring things into my engineering classrooms that are a little different because I've had experiences going to ballroom or from my psychology classes, and it's simply just like having a broader knowledge and a broader understanding of like what the world is out there that is going to bring some like crucial knowledge into engineering.
All right, well, thank our panelists for answering all of those questions with a round of applause. You all are free to exit the stage whenever you'd like. For BSc, maybe grab your tablecloth if you want to take that to the table outside. So as a reminder, I'm going to ask you all to please remain seated and please remain silent for just a few more minutes. Silence, please. So as a reminder, once the screen comes down, you will have access to the QR code that you'll be able to access for your class assignment. You should not leave this room until you fill it out completely. And if you do have questions that you want to ask of our departments that you weren't able to feel like you got from the presentations, please visit their tables as you exit the auditorium in a calm and orderly fashion. Thank you all very much for being here tonight.